What makes the Linux kernel process scheduler so efficient? Imagine a busy kitchen where chefs need to share ingredients and tools without wasting time or causing chaos. That's similar to how the Linux kernel manages multiple tasks on a computer. The process scheduler is like the head chef, deciding which task gets the CPU's attention and when. Its efficiency comes from smart ways of balancing fairness, speed, and adaptability. At the heart of it, the scheduler chooses which process runs on the CPU, how long it runs, and when to switch to another. It uses tiny slices of CPU time called time slices. These slices are so small that the system can switch between tasks quickly, making it seem like everything is happening at once. This rapid switching is called multitasking, and it keeps all processes moving smoothly. One of the main reasons the Linux scheduler is so good is the completely fair scheduler. This system makes sure every process gets a fair share of CPU time. It keeps track of how much CPU each process has used and makes sure none are left waiting too long. It uses a special kind of tree structure that helps it pick the next process to run very fast. This means no process gets ignored, and the system stays responsive. Linux also supports different scheduling policies for different needs. For example, real-time tasks that need to run immediately use special policies to guarantee quick execution. Normal tasks, like your everyday apps, use the FAIR system. This layered approach helps Linux handle many kinds of work efficiently. Preemptive multitasking is another key feature. It allows the scheduler to interrupt a process if a higher priority task needs to run. This keeps the system responsive, especially for things like typing, video playback, or voice calls. The scheduler uses flags that tell it when to switch tasks, often triggered by timer interrupts. Each CPU has its own run queue, which is like a list of tasks waiting to run. The scheduler uses quick algorithms to pick the next task from this list, reducing delays and making multi-core systems work better. This setup helps the system scale well as more CPUs are added. The scheduler also adjusts process priorities dynamically. If a process is behaving well or the system is busy, it can change priorities to keep everything running smoothly. It can move tasks between CPUs to balance the load, so no single processor gets overwhelmed. This load balancing improves overall speed and responsiveness. Linux also has special schedulers for specific scenarios. For example, the energy-aware scheduler helps save power on laptops and mobile devices. These different schedulers optimize for power use or for working with different types of CPUs. All these features work together to make the Linux process scheduler very efficient. It can handle many different workloads, from simple desktop apps to complex server tasks, without wasting resources or causing delays. This flexibility and speed are what make the Linux kernel scheduler stand out in managing CPU resources effectively across all kinds of hardware and tasks.